In the name of Allah, in this course, I will talk about the current transformers in the electrical power system. Introduction to the importance of current transformers in the electrical power system. For example, if we have 220 volts single phase load and we want to measure the electric current that will flow in the phase L or the line L, what are we going to do to measure this current? First, we cut the line L. Secondly, we connect the ammeter directly in series with the line L, and thus the electric current that will flow in the line L is measured. Another example, if we have a three-phase motor, 380 volts, 50 horsepower, and we also want to measure the electric current that will flow in the line T or phase T. By using electrical equations, we find that horsepower equals 0.746 kilowatts. This means that 50 horsepower equals 37.3 kilowatts. The electric current equals the value of kilowatt multiplied by 10 cubed divided by the square root of 3 and the voltage and power factor. So the electric current of the motor is 70.8 amperes. We can also directly measure the electric current of the motor by cutting the phase T and connecting the ammeter directly in series with the phase T or line T. Don't forget that in all the previous steps, we measured the electric current by connecting the ammeter directly in series with the line or the cable. Last example. If we have a step-down power transformer with a voltage of 220 kilovolts and 66 kilovolts and its power is 40 megavolt amperes. So the voltage on the primary side is 220 kilovolts. The voltage on the secondary side is 66 kilovolts. To calculate the rated full load current on the primary and secondary sides of this transformer as follows. The rated full load current on the primary side equals the rated of power of 40 megavolt amperes multiplied by 10 to the power of 6 divided by the square root of 3 and 220 kilovolts and 10 cubed. So the primary current equals 105 amperes. To calculate the rated full load current on the secondary side, we use the same previous equation, but we put 66 kilovolts instead of 220 kilovolts. So the secondary current equals 350 amperes. If we want to measure the electric current that will flow on both sides of the transformer, can we do that using an ammeter as was done previously with the motor? In another way, can we cut the 220 kilovolt line or the 66 kilovolts line and put a series ammeter to measure the electric current that will flow on the line as was done in the case of the motor? It is impossible to use an analog or digital ammeter directly with these high voltages. Again, it's impossible to use measuring or protective devices directly with these high voltages. Finally, measuring and protective devices can measure hundreds and thousands of amperes, but with voltage levels up to 600 or 1000 volts. So, what is the solution to use the ammeter device in our case of a power transformer? In general, what is the solution to use any measuring or protective devices in the case of high voltage or extra high voltage? Like 66 kilovolts, 220 kilovolts, 400 kilovolts, or 500 kilovolts. From here, I start to explain my course and talk about the importance of using current transformers in the electrical power system. So, the main functions of using current transformers in the electrical power system are: first, make isolation between the electrical equipment of medium voltage, high voltage, and extra high voltage, and measuring and protective devices that operated at low voltage. Second, reduce high currents to low values to suit measuring and protective devices. The standard low currents are 1 ampere or 5 amperes. Example, current transformer to reduce 600 amperes to 5 amperes, or another current transformer to reduce 2000 amperes to 1 ampere. Referring to our previous example of the power transformer, to measure the electric current on the primary and secondary sides, first, a current transformer must be placed on the primary side and its voltage is the same as the line voltage that will be installed. So, we put a current transformer of 220 kilovolts. Also, we put a current transformer on the secondary side and its voltage is the same as the line voltage that will be installed. So, we put a current transformer of 66 kilovolts. Then, the ammeters or measuring devices in general are connected to a secondary circuit of the current transformer with a low current value as shown in the picture. Here we see a current transformer connected in series with 11 kilovolt bus bar placed inside a medium voltage distribution switchgear. We see also the secondary terminals of the current transformer, or the terminals 1S1, 1S2, and 2S1, 2S2 that carry low current or secondary current to the current transformer, to the measuring devices and the protective devices, as we will know in detail later. Thank you.